Bismillahirrahmanirrahim. In our today's lecture, we will discuss about the numericals of chapter number 1. Astronomers usually measure astronomical distance in light years. 1 light year is the distance that light travel in 1 year. एस्ट्रोनॉमर जो है एस्ट्रोनॉमिकल डिस्टेंस को लाइट ईयर में मेजर करते हैं और 1 लाइट ईयर वो डिस्टेंस होता है जो कि लाइट एक साल में ट्रेवल करती है. If the speed of the light is 3 into 10 की पावर 8 मीटर पर सेकेंड, what is 1 light year in meters? अगर स्पीड ऑफ लाइट 3 into 10 की पावर 8 मीटर पर सेकेंड हो तो 1 लाइट ईयर जो है वो उसमें कितने मीटर्स होंगे? We have to find the distance. So given data t is equal to 1 year, which can be converted into seconds as 3153600 second. Further, v is equal to 3 into 10 की power 8 meter per second, and we have to find the distance. Solution, as we know that s is equal to vt. By putting the values of v and t in this formula, we get 9.5 into 10 की power 15 meters. So this is the required distance. Numerical number 1.2. Write the estimated answer of the following in standard form. Part A. How many seconds are there in 1 year? Part B. How many years are in 1 second? कि एक साल में कितने सेकंड होते हैं हमने ये भी फाइंड करना है और एक सेकंड में कितने साल होते हैं ये भी फाइंड करना है. सो पार्ट ए, 1 year is equal to 365 days, 24 hours, 60 minutes and 60 seconds. After solving it, it becomes equal to 3.1536 into 10 की power 7 second. It can also be written as 3.2 into 10 की power 7 seconds. Part B. As we know that 1 year is equal to 3.2 into 10 की power 7 seconds. So 1 over 3.2 into 10 की power 7 years is equal to 1 second. So 1 second is equal to 3.1 into 10 की power 8 years. Numerical number 1.3. The length and width of the rectangular plate are measured to be 18.3 cm and 14.60 cm respectively. Find the area of the plate. We have to find the area and state the answer to the correct number of significant figures. Given data, length is equal to 18.3 cm and width is equal to 14.60 cm. So A is equal to question mark. Solution, as we know that A is equal to length into width. By putting the values of length and width, it becomes equal to area is equal to 267.18 centimeter square. Since the least accurate is 18.3 having the 3 significant figures, so the appropriate precision is up to 3 significant figures. Hence, area is equal to 267 centimeter square. This is the required answer. Numerical number 1.4. Find the sum of the masses given in kilogram up to appropriate precision. कुछ मैसेज हैं जो कि हमें दिए हैं, हम लोगों ने इसे इनका सम फाइंड करना अप टू अप्रोप्रिएट प्रिसीजन तक. सो द गिवन डाटा इज masses are 3.197, 0.068, 13.9 and 3.28. Sum is equal to question mark. Solution, sum is equal to, we have to add all these masses and it becomes equal to 20.445 kilogram. Since the mass of least precision is 13.9 kilogram having 1 decimal place, so the total mass should be to 1 decimal place only. Hence, sum is equal to 20.4 kilogram. This is the right answer. Numerical number 1.5. The diameter and length of a metal cylinder measured with the help of a vernier caliper of least count 0.01 cm are 1.22 centimeter and 5.35 centimeter respectively. वर्नियर कैलिपर जिससे लेंथ और डायमीटर फाइंड किया गया उसका लीस्ट काउंट भी हमें गिवन है, लेंथ भी फाइंड करके बता दिया, डायमीटर भी फाइंड करके बता दिया. वी हैव टू कैलकुलेट द वॉल्यूम एंड अनसर्टेनिटी इन इट. गिवन डाटा, least count is equal to 0.01 centimeter, diameter is equal to 1.22 centimeter, length is equal to 5.35 centimeter. We have to find the volume and uncertainty in the volume. Solution: as volume is equal to area into length, by putting the formula of area and radius, that is d over 2, and after solving it, it becomes equal to pi d square L over 4. By putting the values of pi, d, L in this formula, we get volume is equal to 6.250979 centimeters cube. This is the volume. Now we find uncertainty in it. So percentage uncertainty in length is equal to least count divided by length into 100, 0.01 divided by 5.35 into 100, it becomes equal to 0.2%. Similarly, percentage uncertainty in diameter, least count divided by diameter into 100, by putting all these values in this formula, we get 0.8%. Now total uncertainty in volume is equal to 2 into percentage uncertainty in diameter plus percentage uncertainty in length, and it becomes equal to 1.8%. So volume is equal to 6.2509079 centimeter cube with uncertainty 1.8%. As 1.8% of 6.2509079 is equal to this 0.1, so the final volume is equal to 6.2 plus minus 0.1 centimeter cube. This is the required answer. Numerical number 1.6, show that the expression Vf square minus Vi square is equal to 2as is dimensionally correct, where Vi is the initial velocity, A is the acceleration, Vf is the velocity after covering a distance s. हम लोगों ने ये जो थर्ड इक्वेशन ऑफ मोशन गिवन है, Vf square minus Vi square is equal to 2as, इसे dimensionally चेक करके बताना कि वो ठीक है. As given that 2as is equal to Vf square minus Vi square, by putting dimensions of A, S, Vf and Vi, that is the initial and final velocities, it becomes equal to this. Since constant has no dimension, so we write only dimensions on both sides. Hence L square t minus 2 is equal to L square t minus 2. Left hand side is equal to right hand side. So the given equation is dimensionally correct. Numerical number 1.7, show that the famous Einstein equation E is equal to mc square is dimensionally consistent. Given E is equal to mc square, we have to find the dimension of energy as E is equal to W is equal to Fd. By putting the dimension of force and displacement, it becomes equal to ms square t minus 2. Now right hand side mc square, by putting the values of m and c, that is the speed of light, after solving it, it becomes equal to ml square t minus 2. Since left hand side is equal to right hand side, so the given equation, that is Einstein mass energy equation, is dimensionally consistent. Numerical number 1.8, derive the formula for the time period of a simple pendulum using dimensional analysis. The various possible factors on which the time period T may depends are: first one, length of the pendulum; second, mass of the bob; third, angle theta which the thread make with the vertical; and the fourth, acceleration due to gravity. हमें डायमेंशनल एनालिसिस को यूज करते हुए टाइम पीरियड का फॉर्मूला फाइंड करना है जो कि सिंपल पेंडुलम का टाइम पीरियड होगा. सॉल्यूशन: it is given that time period depends upon given factors. So the relation of time period becomes T is proportional to m की power a, l की power b, theta की power c and g की power d. After removing the proportionality sign, it becomes equal to this. This is the equation 1. By putting the dimensions on both sides of the equation 1. So the dimension of time period is t, constant ऐसे लिख लेंगे. Dimension of mass is m, dimension of length is l, dimension of theta is l, l minus 1 and dimension of g is lt minus 2. Now comparing coefficient of m, 0 is equal to a, this is the value of a, l, 0 is equal to b plus c minus c plus d, so b plus d is equal to 0, this is equation number 2, and t 1 is equal to minus 2d, that is d is equal to minus 1 by 2. By putting it in equation 2, b plus 1 by 2 is equal to 0 and b is equal to 1 by 2. The value of c is also equal to 0 because l minus 1 की power c is equal to l in की power 0c and 0 is equal to 0c, so c is equal to 0 because theta has no dimension, it is an angle and angle is a dimensionless quantity. By putting a, b, c and d in equation 1, so t is equal to constant m की power a, l की power b, theta की power c and g की power d. Putting the values of a, b, c and d, it becomes equal to t is equal to constant into l की power 1 by 2 and g की power minus 1 by 2. After simplification, it becomes equal to constant into l over g. So the final answer is t is equal to constant square root l over g.